Hello, everyone, and welcome to our webinar, Talk to Your Web Analytics with AI for One-to-One Personalization. My name is Matt Brown, and I will be your moderator today. One of my main jobs at SingleStore is to organize these weekly webinars, sometimes two or three per week, demonstrating data and AI use cases, new tools, and technologies. I'd love to hear any feedback you have or ideas on future topics or sessions. So if interested, feel free to drop me a note on LinkedIn, and I'll look forward to hearing.
Awesome, Matt. Thank you. And thank you all for being here. Arvind, it's a pleasure to share the stage with you today. We're going to have a super interesting discussion today. And I just want to kind of give you some context on how we at SingleStore here are starting to seeing the industry around AI, around databases, around sort of what Arvind and I are going to discuss today. And the way we are lensing the market right now is that, the future of apps, the future of SaaS apps in a world of AI, is going to be, sort of the merging of databases, applications, and AI in a single place. Traditionally today, SaaS applications, and we've got hundreds of customers here at SingleStore that leverage us for SaaS applications, are essentially a UI of some sort of customer-facing or internal-facing or internet-facing analytics on top of a database. And today, we need that UI for human consumption. In the future, we see the database to be the core for the AI agents on top, rather than just sort of consumer-facing dashboards. And those agents will be what actually drives the concurrency on top of the database in the future, not the dashboards per se. Now, if we look at how we see our customers actually build these analytical applications, AI applications, it typically starts with an open source database, and you have operational streams of data into that open source database. And then perhaps you have some third-party data or just unstructured data into a JSON database, and you have just a little bit of complexity, but it's still okay. And then, of course, you need to speed up your application so you have a cache. And then perhaps you want to add new features. So you're adding a search capability onto that. And then, of course, you have your streaming data from a place like IoT devices or Kafka or clickstream data. And all of a sudden, you've built this sort of application with one, two, three, four, five data sources sort of stringed together. And then, of course, you had your need for user-facing analytics as well. Now, the challenge behind this is perhaps this worked at some point for internally facing analytics apps. Maybe it works for consumer-facing analytics apps, but we tend to see that it doesn't. But now, with the concurrency going, 100-fold, with AI agents on top of your data estate, such a database architecture, such a data architecture is untenable to build agentic apps, and that's kind of what we're seeing with our customers. Now, the simple paradigm, sort of around prototypes for AI applications is I have my LLMs, I have my vector store, and I need to do vector search across my vector store. And this is how we see a lot of our customers leverage databases like Pinecone when they get started, Milvus when they get started, and various different other databases when they get started. Now, what we are finding our customers telling us is that vector store just holds one single dimension of the information needed for the LLM. We sort of, Matt, discussed the lakehouse and our ability to tap into data in your lakehouse. The data lives in the lakehouse. The data lives in that document store. The data lives in the transactional store. The data lives in Kafka. The data lives in all those places that we just showed on the previous slide where you have your complexity. This actually introduces a tremendous challenge for organizations trying to build AI applications, because you have four different places here that need to feed data to an LLM. And then, of course, you have your application layer on top of that. So feeding all of that to the LLM through the application layer becomes very challenging to manage from not just a data integrity perspective, but also from a security perspective. That's just for your retrieval. And then we see customers also try to stitch this together at the application layer, which is hard to prototype. You get more hallucinations. You get a lot more latency because you have 3, 4, 5, 6 different places you're pulling data from. And then data inconsistencies, like I mentioned, inefficiency and inflexibility in your ability to actually go get that data from 5, 6 different data sources. And then ultimately, you're still not getting all the context around the data sources because your schemas are different across different databases. The way the data is structured is different. The way you've queried it and maybe stitched it together through your joins is different. And so application layer stitching for the LLMs is also something that we're seeing to be quite untenable in our customer base. However, here at SingleStore, we give our customers the ability, as Arvind will tell you himself, to take all of that data and retrieve the vector data, the SQL data, the graph data, whatever it is, and give that to the LLM and get the state back from the LLM in terms of the user's history and things like that, and then fine tune and re-rank your results from your database itself, all in a single data platform. Now, what we are seeing, sort of the consolidation in the industry happening, this might be interesting to you guys. What we're seeing the consolidation in the industry happening is not just at the lakehouse layer with your Snowflake, with your Databricks, with the acquisition of Tabular and then the introduction of Polaris from Snowflake. We're not just seeing consolidation happening around Iceberg there. We're also seeing consolidation happening at the operational data layer. Each one of those lakehouse architectures needs an operational data layer for context to feed to the LLM, for context to feed to the customer-facing dashboard, for context to feed to all real-time applications. And that operational data layer, like I just said, needs to be fit for the AI-first world. Now, you see things like real-time time analytics here. You see things like transactions and observability. And that's the sort of, I think, current horizon on which that we lens our businesses, on the way that we build our applications today. But the other things that you see here, like LLM context, the responses, history, knowledge retrieval, building agentic apps, and having AI agents on top of the database, is the next horizon, if you will, of how these applications are going to be built. And your operational data layer on top of your lakehouse or on top of your data warehouse needs to be fit for that next horizon of applications that you're building. Now, let's talk a bit about what that data layer needs. First and foremost, like I mentioned earlier, it's high concurrency and low latency queries. Today, we say things like, oh, my application has 10 users querying it at one time. My application has 100 users querying it at one time. Now, in the AI first world, your AI is generating 100 different hypotheses, different proposals, lensing that in the form of 1,000 different queries to validate each of those and draw a conclusion across your database. So the concurrency, by default, goes orders of magnitude higher. And you need an operational data platform to help you sustain that concurrency on top of your data estate. Now, the next thing that it needs is true hybrid search and multi-model support, which means not just support for your structured data, but also support for your unstructured data and your semi-structured data to do those keyword-based search and those graph-based queries. You saw that diagram of data sitting in 4 or 5 different databases. Now, the beauty of that model is that you can store your data as many different ways as you want. Now, the flaw and the downfall of that model is that your data is in 5 different places, managed security in 5 different ways, in 5 different query types. With the operational data layer, you need a single place that allows hybrid search and is multi-model to query that data. And finally, the integration layer to stitch all of your data points together. Stitch your real-time events, stitch your Iceberg integration, and have that row-level security, and the enterprise-grade security and consistency to handle the data from your entire data estate in one operational data platform. The question I would ask here is, if an agentic app or an AI agent runs a delete query on your sort of AI application, and it has to go across 5, 7, 8, 10 different databases to do that, do you trust it? Or would you rather it come to a single operational data layer and run its app and run operations, transactional and analytical operations with high fidelity in a single database system? So let's just sort of talk about how some of our customers have done this on top of SingleStore. So as many of you may know, some of you may be new to SingleStore. SingleStore started as a company called MemSQL in 2011, and we have grown tremendously since, transitioning from MemSQL, an in-memory database, into SingleStore, which is a database built for intelligent applications, combining both transactional as well as analytical capabilities in a single database, multi-model in a hybrid multi-cloud fashion. Now, that's a lot of words. What does that mean? That means we can do in-memory OLTP, OLAP in a single table type. With vector search and full text search, you see that came in 2017. We actually had a customer go live in 2017 with an image recognition app, not generative AI, but true sort of essence of where AI started in terms of image matching, video recognition, things like that. We got the patent on our universal storage technology in 2019 when we also launched our cloud service, where we now have 200 plus customers. And in the last 2 years, we have heavily strengthened our multi-model and JSON analytics capabilities, adding then index vector search in the last year to enhance those capabilities we got in 2017. And we've crossed $100 million in revenue and more than 350 customers. Now, we talked about multi-model being the sort of core need for one of the core three needs for the data platform. Essentially, what you'll see and what Arvind will talk through is the ability to get data sources from Kafka, from CDC sources like MySQL and Mongo, unstructured data and vector data, index that in real time and bring that into a place where you can run transactions and analytics and search applications in a single database on top of Snowflake, on top of Databricks, IBM, AWS technologies, with that common thread of Iceberg, giving you the ability to access all of your enterprise data in an operational data store with sub-millisecond response on your inserts, updates, and deletes for building those intelligent applications like Arvind's going to walk you through today. So in summary, or in short, we are this sort of single database layer, operational layer for your real-time data on top of your transactions, on top of your analytics, and on top of your search applications to do fast updates, to the tune of 12 million upserts per second, like Akamai does with SingleStore, to do sub 10 millisecond analytics on 2, 3, 4 petabytes of data, and to run true search applications on SingleStore, like some of our largest cybersecurity clients do. And these are just a few stories. Our customers are building on their intelligent applications with Gen AI workloads every day. These are 3 customers, one of which is Arvind, you'll hear from shortly. These are 3 customers that started with core SingleStore for transactional and analytical use cases, and have built on top of that generative AI applications, meaning-based search, built chatbots, and built AI-driven analytical interfaces on top of their existing data estate on SingleStore. There are many other customers, Dataloop, Lumana, Directly Apply, Thorn, RightSense, and several others. 15% of all SingleStore cloud customers are using vector search today. And so hundreds of AI startups are being born today on SingleStore in our trial experience, using our free shared tier, by the way, that Matt mentioned earlier. And of course, it's not just that. You also have some of the leaders in their industries, like Goldman Sachs, like Kakao, like Comcast, like Palo Alto Networks of the world, leveraging SingleStore to build their not just analytical applications, but as well as but also their AI applications on top of SingleStore. And you can build those apps for free here on top of the SingleStore free shared tier, as I just mentioned. So I'm sure we'll pop this up again later and give you access to it. Now, Arvind, I'm going to actually give you the share so you can guide your own slides. Pleased to introduce Arvind Murthy, a longtime customer of ours, and somebody that we're super, super proud to collaborate with. So Arvind, the floor is yours.
Hey, hi, Sarang. Thanks for having me. Let me just share my screen. All right. Can you see the screen?
Looks great.
Yeah, looking good.
All right, cool. Yeah, so myself, Arvind, co-founder of Actors.ai. We are a B2B marketing, analytics, attribution, and activation platform. And we have around 300 customers currently and growing. So, bit about what we do, right? Like, So when I say B2B marketing platform, what it means is that at a high level, we for any B2B marketer, let's say we're taking example of SingleStore itself, uh, 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 you would run campaigns across multiple channels. The buyer is actually um, interacting with at different places. The buyer might be seeing an ad on LinkedIn, might be visiting your website, interacting with the blog, looking around for some, let's say, vector database, and or searching on Google and clicking on an ad and so on, right? So the intent and the interactions are happening at multiple places, including the website. So we kind of map together the entire journey, user journey, and also we do it at an account level, meaning at a company level, right? Which is basically that not just the user journey matters, but there could be like multiple buyers within the same company, and we need to kind of group together those journeys and build a unified view of the data, right? So once you do that, on top of this data, what we provide is analytics capabilities primarily, and web analytics being a part of it. But the thing is, like, you could use GA for web analytics, but that by itself is not great, because you need kind of all of this auxiliary information where you get all of this event stream data from different sources, along with enriched profile information both at the user level and account level. So what we do is we not only map the data from the customer sources, but we also enrich it with third-party data sources like Sixth Sense, Apollo, Clearbit, etc., to build very rich company and user profiles on top of the web analytics data, and give dashboards uh, and analytics capabilities on top of it. So once that is done, you can, let's say, you want to target a segment of accounts um, who are, let's say, in a given revenue range, let's say 100 million to $500 million, right? And who have kind of um, interacted with, who have read a blog on vector database, right? And are currently in the market, right? And are looking at the pricing page or some other page, right? So if you want to kind of run a campaign, you need the ability to have all of this data at one place and run all this and segment the data in a way that you can kind of capture the interactions across different channels, and also the the kind of companies that you want to target, right? So you can build such fine-grained account segments, and you can also have, like, if the segment is large and you want to kind of prioritize among them who to reach out to, you can also score the accounts on top of the data. And once you have these segments, what we do is, now that you know who are the ones actually interacting, and what are they looking for, and in what stage of the journey they are in, you can trigger workflows on top of these segments. Like whenever somebody does an action, or when they enter a segment, you could trigger a workflow, and you could send all of this information either to the CRM, or you could or to a sales sequence, or to a chatbot if they're on a website, and kind of based on all the context that you have, you can actually send hyper personalized messages for them, or hyper personalized campaigns for them to actually to make it most relevant to the audience, right? So yeah, so all of this data intelligence, segmentation, etc., is being done for us on SingleStore. SingleStore is the primary data store and the only data store for us. And the reason that we went with SingleStore is, one, it's distributed, it scales efficiently, and it works for both transactional and for analytical loads. So when I say transactional, we have a lot of incoming streaming data that's coming in. And on top of that streaming data, we have a lot of updates also happening. Like when you're on a website, you scroll the page, we capture the scroll percentage, we capture the amount of time that's being spent. We have a lot of information coming from the CRM regularly, and so on. And you also have the application which the customers are using, and the API requests that is coming from the application and updates from that part, right? So there's a lot of transactional data coming, but there's also analytical queries that's being run, the dashboard widgets, etc. That needs to be powered, right? And having like the old world was like you have like a transaction Postgres for transactional data load and something like a data warehouse for analytical loads. That is too complex to maintain, and this kind of simplifies the whole thing for us, right? Once we were able to see that I mean, we were confident about analytical loads, but once we were able to see that it works well even with transaction loads, it was like a no-brainer for us from that. And the other reasons are being a SQL compliant. But while being SQL compliant, we have a lot of schema-less data that keeps coming in, right? Which is because there are a lot of filters and properties that come in, key value pairs that come in, which is not predefined, which and it depends upon the data source from which it's coming in. And there are a lot of updates also happening on those JSON, and a lot of querying also happening on those on the JSON data stores. So you have both the best of both the worlds. You have SQL and with very fast JSON both for querying and for updates. You have a schemaless kind of data store that comes in, and both kind of fits it together for our application. So what's the um, so let me just share the other screen. Yeah. So I'll briefly go to the demo. So what we have in the product is basically so what we have in the product basically is uh, uh, so once you have all the data, this is one of the views where you can create a lot of reports, dashboards, and within dashboards you can create a lot of reports based on data, right? And there are different kinds of reports you can build. You can build like a funnel report. You can build a metric report, and so on. And on different data sources. It could be on website data. It could be on let's say your CRM data, and so on, right? And there are also other parts of the product like segmentation, workflow, automation, and so on, right? So for a power user, I mean, unlike a traditional, let's say, Power BI kind of solution, wherein you have to write the SQL query to get these widgets, we have a good interface wherein you don't have to write a SQL query, but you can kind of you have a way to kind of build out the query depending upon the kind of report that you want, right? But though that is useful for a power user, let's say a non-power user who just wants to come and just get some data out of this, right? So for those kind of users, we started off with some very simple applications wherein they can kind of easily ask the question that they have in mind without having to figure out how exactly to do, right? So we have started with mainly with the web analytics use case. And let's say now you're here and you just use the search bar and you can just search for, let's say you want like a simple thing as the total number of sessions uh, uh, that uh, uh, that happened last month, right? That happened. So we're just launching this. Yeah. So this is the number of website sessions that has happened. I'm using it on our own data, and you can see that it kind of mapped to the right KPI, and the date range is also last month, and this is the total number of sessions. There are a number of metrics that we provide, and it kind of maps to the right metric over here, right? So that's one use case. Uh, um, Now let's say you have started a campaign, right? And you want to kind of know whether this campaign, whether the landing page is right for the campaign, and are people engaging or just leaving the site, right? So there's a metric called bounce rate, uh, uh, where campaign is, you kind of remember that the campaign name is search brand, related to search brand. So you say TDD search brand, right? And you right? And in this case, you have the bounce rate that's been set, and the filter among the multiple filters that you have, it has identified the right filter to apply called session campaign. And also the filter value, which is basically TD search brand. I mean, I just without it has mapped that to the right value that's required for this, right? And you get the report out of box, and you can further break it down by any other thing that you want over here and take it forward. Right? And now let's say we want to kind of understand, as I said earlier, that the main use case is by marrying not just looking at website data, but also website data along with other third-party information that comes in, right? So let's say you want the bounce rate, or the bounce rate, or you could say um, and a good engagement metric would be the amount of time spent in each website session. So you could say session duration, um, uh, break it down by the company revenue range. Right? So you have different kinds of companies and different revenue ranges, and you would have an opinion about which company or which revenue ranges to target, and you want to see which actually you might have launched the campaigns for a given ICP, but that ICP might not be engaged. So you could now here you see that the KPI has been chosen as this session duration and the revenue range as a breakdown component, and you get a report based on that, and yeah, and you can check whether the right companies are engaging on the website, right? So this is some we started off with some simple use cases, and we kind of looking to build on top of this to uh, uh, more complex use cases and to all parts of the product. Right? Um, so I'll just go back to the slides uh, to give an overview of how we actually do it. Yeah, so the way we have implemented this is basically what is called as retrieval augmented generation based architecture. So what happens is the end user fires a query from the browser in text. So we don't do text to SQL directly because the one it's not easy to kind of put in all the domain knowledge, and also we want the final UX to be open, so we are converting the text to an API query that will hit SingleStore at the end, our SingleStore database, and fetch the results. So the end user types the query in natural language. It hits our application it's integrated with the LLM, and that query is sent to the single store vector database, wherein we have a lot of sample or a lot of example queries and the JSONs that is expected. And this, so what the intention here is to convert the natural language query into a simpler JSON structure, which can then be converted to an API, right? So those examples are stored in single store vector database, and we get back the JSON query examples. And now these examples are given as context to the LLM, and then we try to parse the given query, right? In step 3, right? So we use OpenAI LLM here, and the OpenAI LLM then parses the input query into a JSON query structure, and then returns back to the app. The app then does some preliminary checks on whether it has parsed it right, whether the value that the LLM is giving a known value. Do we know the key? Do we know the value? Is it an acceptable value? And then it converts that into a larger API payload and an API endpoint that needs to be hit by the browser. And that gets sent back to the browser. And now the browser knows the API endpoint and the context or the component that it needs to open. It opens the corresponding component and hits a corresponding API and fetches the results and displays the report. So as Sarang said that the main use case that we see here is that of simplifying the UX for the end user. And we're trying to keep uh, the same screens, but make it more accessible and with natural language. So going a bit now, the main problem that comes, especially when you're thinking of text to SQL or text to an API, is not having enough data, especially with the domain knowledge, to kind of parse the input query and generate the outputs, right? So what we have done here is basically uh, as you're seeing, right, the amount of combinations of context that is required is also very high, right? So because there are each drop down or each let's say column in our analytics table has a lot of different values that it can take and a lot of different keys also that it can take. So what we have done is we have generated few query templates on the kind of questions that people could ask, and on top of that we have made added in these variables, and we kind of iterate over some known uh, questions that can be asked, or the key values that can be asked, and generated the query to the expected JSON structure. And once we get these sample examples, I mean, it's not sample, we generate around like 100K examples. We then convert it into an embeddings. And for these embeddings, we're using BERT open source because we don't want it's just for retrieval. And once you get those vectors, we store it in the single store vector database, right? So once that is done, let's say when a question is asked, right, let's say bounce rate last week, though the exact same question might not be there, you might get some variants of the question that's already there. Yeah, like you might get website sessions last week as a variant, as an example in the database, and probably bounce rate last month, right? What happens is that once we take these matched examples and give this as context to the OpenAI GPT-3, and then give the given question, and given the context of the match examples and the given question, it can parse the question along with some checks and balances that that uh, uh, I think my connection is a bit flaky. Can you hear me
We
well?
had a connection issue, but it looks like you've reconnected. I think it's good again.
Okay. Should I go back to the previous slide, or can I just continue from here?
Just like 10 seconds worth, I think, was lost.
All right. So yeah, so we get so broadly once a query is fired, we get the nearest matches for those queries and use those queries as context and hit OpenAI, and OpenAI is able to kind of GPT-3 is able to kind of parse the given example, even though you don't have the exact example, and get the JSON, which we then convert to an API request and then hit our product. Yeah, so that's the broad flow. The way we look at it is we will kind of write when this can be thought as an agent which kind of can do web analytics and crunch the numbers given a query. So we plan to write more such agents, individual agents, which can uh, uh, interact with different APIs and different parts of the data, and can also, let's say, segment accounts and an agent to kind of activate the workflows, to configure the workflows, and so on. So once you have many such agents, the idea is then you can have one more layer of agents which can actually break down a goal into tasks and kind of distribute it among all the agents so that it can crunch the numbers and then figure out what needs to be done and kind of take an approval from the human and then kind of activate. And the end user can give a large goal like saying, can you just increase the ROI for these, let's say, LinkedIn campaigns, and it'll exactly figure out what needs to be done looking at the data and what has worked historically in the past. That's like the broad direction that we are going using LLMs and SingleStore. Yeah, that's it from my side. I think we can move on to questions.
Awesome. Really good stuff. I know we've already had some questions come in. We definitely have a few minutes for more questions. So if you've got something, feel free to put it into the Q&A. There's that button at the bottom of your console. One that I saw come in, Arvind, which I think I'll pose to you. Did you only use OpenAI's GPT-3? What about 4 or 4.0?
Um, so we use GPT-3 and with are so this was more like the use case is not that of generation per se. The use case is more of learning to parse from context. So GPT-3 worked well for us, and we haven't upgraded, but we need to try once on GPT-4 and see whether there's an improvement. But I think for this use case, I don't expect a lot of difference between GPT-3 and GPT-4.
Good stuff. I see a outstanding question here about can you walk through the code? I don't know what you're willing to share and not willing to share, but anything you want to talk through there?
Code, I don't have it. Yeah, I don't have the exact code like uh,
No worries.
that we opened up and
Um,
shown, but do something later on.
okay. Sarang, I see one here about GraphDB capabilities. And I think Akmal talked a little bit in the chat about recursive CTEs, but do you want to talk a little bit about that?
Sorry, what was the question?
About GraphDB. Do you have GraphDB capabilities?
I, generally speaking, single store can help enable knowledge graphs. Yes. Are we a natively, do we have native support for graphs? No, we're not a graph database. Not like a Neo4j or others like that. No.
Good stuff. I'll stick with you for a second here, Sarang. I see one came in here. Can you expand on JSON API converter part of the process?
Yeah, certainly. So I'll give you guys just a quick overview of our JSON capabilities. So single store supports natively JSON columns, so you can have a column type that's JSON. You can also, on ingestion, take a JSON and parse it out into several other columns that are not JSON columns. So two different ways of doing it. In terms of actually running analytics on that JSON data or running operations on that JSON data, single store is extremely fast at doing point reads and writes on specific elements of JSON objects, as well as doing large scale aggregations on even sparse JSON objects within a given column. So that's just sort of on the JSON capabilities. Now, what you also might be alluding to is our single store Kai capability, which enables you with a MongoDB API. If you leverage MongoDB today, you can actually do live change data capture in from MongoDB, make no application changes, and point your app directly at SingleStore for doing analytics on or even transactional reads on data that was in Mongo in SingleStore. So we've got that capability sort of at the API interface layer, as well as strong JSON capabilities in the database engine as well.
Awesome. Thank you, Sarang. I just put the link to that single store Kai in the chat. Arvind, I'll go back to you here. Did you run into any latency issues with GPT-3 responses?
Not per se. Like the demo that I showed was hitting GPT-3 in real time, and overall, the entire vector DB search and then hitting GPT-3, getting the response, and then converting the response into an API and showing. So in a matter of seconds, the whole thing is done. So overall, we haven't seen from a UX perspective, it doesn't seem very slow. So we haven't gone to evaluate a lot and optimize on that.
Good stuff. Sarang, I'll come back to you. I know there was a question earlier about cybersecurity customers. And I know I ended up posting, and I know Akmal answered a little bit in the chat. We talked about our experience with Arcules and Nucleus Security, a couple others. I wonder if you want to talk about, I know you have more hands-on experience with customers than anyone on the panel today. I wonder if you want to talk a little bit about either cybersecurity or just like use cases that you see SingleStore working really well for. What do you think?
Yeah, for sure. Look, I think we'll start with cybersecurity. Cybersecurity is a huge vertical for single store applications. We've got the likes of Arculus and Nucleus that Matt mentioned. We also have Armis, Palo Alto Networks, and some of the largest security companies in the world leveraging single store. Now, what is core to those applications that are cybersecurity, whether it's cybersecurity or it's ad tech or it's martech or it's fintech? The reality, the sort of common thread across all of those is that you're monitoring something. Like Arvind's talking about, you're monitoring various different customer channels, marketing channels. In cybersecurity, you're monitoring different threat bases or just different streams of data, right? So monitoring different streams of data, those are your transactions, and the ability in an operational data layer, in an analytical layer, to consume those events in real time, to run analytics on them, and to be able to interact directly with an LLM with all of that context is what makes SingleStore unique. So in summary, the ability to work across all of those verticals comes from our capabilities of transacting on data in real time, analyzing, and then contextualizing that data, all with millisecond response times.
Awesome. I'll give you one more, Sarang, as long as we're on you. And I know Akmal is busy typing on this one, so he might want to chime in too. But the question is, can your product search over the content of different types, like doc, PDF, of company documents through the hybrid search? And I know we've got some features coming up as part of 8.7, but Sarang, I wonder if you want to talk to that at all.
Most certainly, yeah. My team has recently done a couple POCs with very large banks where they're consuming large PDFs to the tunes of thousands or tens of thousands of pages in PDFs. Consuming those, vectorizing those, getting the embeddings in them, and then actually running hybrid search queries on top of them, sub 10 millisecond response times. Now, the key to that in a bank, if you think about it, is you have the PDFs, but the context of the PDFs, what those PDFs mean, who the people are referenced in those PDFs, who the companies are that are referenced in those PDFs, is all relational and unstructured data separate to those PDFs. Now, if you were to use a vector database for this approach alongside your data warehouse or your data lake, you're starting to stitch together various different data sources, which makes it extremely difficult to track the fidelity and the security of the answer that's being responded, that the answer that's being returned to the user. The reason that these people select SingleStore for this use case is the ability to handle those vectors, from those PDFs, along with all the contextual data, directly, backing that chatbot or backing that interface, that AI agentic interface, to serve the needs of the consumer. Hope that helps.
Awesome. Arvind, couple questions for you. First one, which embedding model was used?
Which embed,
For BERT.
so we use BERT embedding. I don't remember the exact version of BERT, but I think it should have been the latest version of BERT available. And we went with a simple model which could fit in memory and the idea was to generate embeddings, which is good enough for search, right? And for the use case, like probably even a token-based search would have worked, but uh, I think I mean, we didn't try like using Llama or some other model yet, and not sure about the improvement that we'll get over there. I mean, we need to check on that. But we didn't face any bottleneck in terms uh, of bad quality matches coming because of the embedding that we have chosen, right? And we start off with BERT and 32 the vectors of size 32 bits, 32 floating point numbers, and I think that worked well for us.
Good stuff. I see another one here for you, Arvind. Will you be adding the future capability of summarizing insights from the generated dashboards?
Yes, so that is so there are two parts to it. One is kind of summarizing the data that is already there. So we have uh, so we like we the widgets that come out has the data and also the tables that come along with it, which is more like a CSV kind of data. So summarizing, like, yeah, understanding the data is the hard part, right? Like you look at number, what you interpret out of it is the hard part. So that is the that we're trying out some POCs on that, and that will be coming out soon. But the bigger thing is within the data, there are a lot of insights that's already there. Like we launched a feature called Segment Insights, which when you build out a segment, it shows the insights within that segment, and that kind of compares the journeys within this within that segment, and figures out the inflection points in that journey, and kind of highlights those, right? So both kind of insights are coming where we use data mining techniques to pull it out, and also of the reports that have been pulled out, summarizing it to insights.
That is very cool. I cannot wait to see that. We might have time for one or two more questions, but I should probably get started with our wrap up announcements and get to that raffle winner. So just a reminder again, we've got several great sessions that are coming up over the next several days. I've just put them into the chat. There's the June 19th, that's tomorrow, step-by-step guide to real-time product-led growth, segment and SingleStore. That's tomorrow, RSVP link in the chat. Then next week, we've got using AWS Bedrock and LangChain for private LLM app development. Akmal here will be the presenter then. And then our big new release event, June 26th, Unfreeze Your Iceberg Data for Real-Time AI. If any of these topics are interesting, take a look. The RSVP link is in the chat. I hope to see you at one or maybe all of them. The announcement you've been waiting for, today's raffle winner goes to Anup Mahadev, Senior Software Engineer at Visa. Congrats. Thank you for joining. It'll be your choice, AirPods or the Ray-Ban LLMs. If that's not you, don't give up. We are going to give out one more raffle winner later today to someone who has tried out SingleStore. So again, we've got that free forever tier. Give it a shot, sign up, and we will announce one more winner before the end of the day. Thank you, Sarang and Arvind, for today's presentation. Thank you, Akmal, as well, for joining our Q&A panel. Thank you to our audience for joining. We really value your time and joining us today. So thank you. Have a great rest of your day. Bye, everyone.
Thank you.
Bye-bye.